this works. Well, it kind of works. Yeah, there we go. All right. Hello, 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 hello. Hello, everybody. How's everybody doing? Hopefully, stream is working really well today, so pretty happy about that. Ooh, hello, planet. How are you? I hope you're doing well, my friend. I did enjoy my weekend, Chase. Yeah, had a nice Labor Day weekend. Got a chance to relax, play a little D&D. Nothing wrong with that. How about you, Chase? What did you do for Labor Day weekend? Oh, there you go. Labor Day grilling. There you go. Nice, nice. Man, my family hasn't had a grill day in a while. Shoot. Usually my mom makes like these kebabs that are really outstanding when you grill them and stuff. Oh man, I missed that time. Grilled chicken, some grilled steak chunks. There you go. Mm mm mm. I just ate two. Why am I getting hungry again? That's pretty bad. Oh man. Wait, we're gonna get started here a little late because I got here a little late. So we'll get started here in a few minutes. So let people start coming in for today's lecture. So got some stuff here to do today. So I don't want anybody to kind of miss out. Be starting off with the end of section 2-4, then working our way up. So yep, okay. Yes, that is what we are doing. You got a favorite food there? Sure. Hopefully there'll be a few more people coming on in. Whew. All right. Pizza's the best food. Hey, JTS. Hey, Gerda. Pizza is pizza is the best food. This is true. Any word on the exam? We're not done with chapter 2 yet. So until we get done with chapter 2, I'm not going to tell you when the exam is going to be. That's pretty much it. It's as simple as that. So, like I said, like I'll say here, it's either I can make that announcement next class or I'll make that announcement next Tuesday. So, one of those 2 days, I'll definitely be making an announcement in regards to that. Just depends when we get finished with the material. So, Planet, how old do you think I am? How old do you think I am, and how old does your sister think I am? 21? Damn. I wish. Yeah, that's back in the day. I still have my old ID from way back when. 28. 28, man, I feel bad. I wish I was 28. Bubbly Snowflake, thank you very much. Thank you, Bubbly Snowflake. I really appreciate those kind words. That's very nice of you to say. Early 30s. Early 30s. Okay, I'll take that. My face actually contradicts my age. I know that. If I shave my beard, then I'll look 28 for real. Like really. Like if you'll see me, I'll shave my beard off for my next class, for the next time, and then you can determine if I look 28 or not. But in all honesty, my birthday's in 12 days, right? So I doubt you would believe me even if I told you. But I can tell you it's not a problem. So this shocks a lot of people just because age is a number, but you act the way you do, so it is what it is. Good, we got a few. Yeah, a lot of people say that for about me is I still got a baby face, so yeah, I'm actually gonna be 41 in 12 days, so yeah, go flip and figure. Are we continuing on with question 8 of 2.4? Yes. Yes, that is exactly correct, Chase. That is exactly where we're going to be starting off today. Oh, wait, just one more minute here. Hopefully, we got a few more people starting to come in and we'll be okay. I mean, I could tell you what I was doing when I was 28. I was living in Japan when I was 28. I mean, those were fun times. Boy, that New Year's. Whew, mercy. Not one of my finest nights. You'd like to move to Japan? It's possible. You certainly can. I did a lot of research. I moved to Japan. That's the odd part about my I don't know how would I put this here, but the odd part of my timeline is that I got a master's degree and then I moved to Japan for teaching English that had zero or little to do with my master's degree because I just, I think it's one of those things that you would regret not doing. So I was like, why don't I go ahead and do this before I regret not doing this? So that's what I decided to do. And I still to this day do not regret moving there for 4 years. Loved every second of it. Yeah, I'm actually surprised. There we go. Thanks, Chase. I really appreciate that. Japan was definitely a fun time. So the crazy ups and downs, I gotta tell you, wouldn't trade that for the world. All right, I think we're ready to get going. So let's go ahead and get started here. So okay, let's go ahead and get started here for today. Let's get started today. Welcome back to Tuesday. Hopefully, everybody had a very nice and wonderful Labor Day weekend. Oh, I could go on from Japan for days. The good side, the bad side, everything. Um, Well, welcome back. Welcome back Tuesday. Hopefully, I had a very nice Labor Day weekend. So, today we're going to finish off here section 2.4. We're doing that last question there, question number 8 from the handout from last time. We finished up everything regarding parallel lines, perpendicular lines. We talked about horizontal, vertical lines as well. All right, the slope between 2 points, point slope formula, things like that. All right, now, the last question here from this handout is going to be in relation to one of the questions here already from that same exact section. And so let's go ahead and take a look at it right now. All right, so that is going to be number 8, which is how do we find the average rate of change? All right, now another way we call the average rate of change is we also call this the slope of the secant line. So this is also known as the slope of the secant line, aka the slope of the secant line. So if you see questions that says, oh, okay, can you tell me what the slope of the secant line is? You're like, okay, here you go, slope of the secant line. Now, another way to kind of call this question to make this as easy as possible is essentially you're basically what's the thing here? What's the key here? The key is that you're finding the slope between 2 points using an interval and function notation. Honestly, there is literally no difference between what you're doing as a what you're doing as a with 2 points and function notation. Like that's it. There's literally no difference. So if you remember here, let's go back for just a second. If you remember here, we did talk about this last time. We said, all right, if we wanted to find the slope between two things, that was y is equal to slope is equal to y2 minus y1 over x2 minus x1. All right, so this is what we talked about last time. Like, we got the 2 points, we plugged and chugged the numbers in, churned out some random answer, and that's the slope between those 2 points. Fair. All right. So then, how do I express the average rate of change if it pretty much means exactly the same thing, just with different notation? Well, let's talk about the second half here. It says I'm using an interval. An interval, you're like, alrighty, interval. All right, what interval are we talking about here? Well, let's take an interval here with a comma b. A is going to be the first x value, and b is going to be the second x value. All right. So if I want to find the average rate of change, go ahead and put this down here. So the average rate of change here is going to be reflected like this. We're going to have, notice we have x2 minus x1. Well, b could be my x2 and a could be my x1. So I just replace that with b minus a on the bottom, just like I do in this previous guy right here. Really, that's the only, I'm just swapping out these two guys with b and a instead. Okay. And what about y2 and y1? Well, I said we do have to use function notation, right? I got to use function notation here. So because I have to use function notation, and probably should shrink that down. Go. There we go. This a bit smaller. Okay, there we go. All right. So because we have to use function notation here, in this case, well, how do I rewrite y's in terms of function notation? Well, I can rewrite it as f of b minus f of a. Because remember, f of x is the same thing as y. All right, so what's y2? Well, y2 is what happens at, what's y at the second x value? What's y at the first x value? Okay, and that's about it. That is exactly what the average rate of change is, or aka the slope of the secant line. Seriously, that is legitimately, that's it. So let's do an example. Let me go ahead and showcase how this works. It's like super straightforward. So let's take a function here, and then we'll take an interval for that function, and then we'll find that average rate of change. So let's say the function here is let's say, oh, oops, meant to put an x there. Let's say 2x squared minus 5x plus 3. All right, so let's say this is our random function here, and we want to look at this over the interval. Let's pick a random interval here, -2 to 5. Okay, so this is our random interval right here. Okay. Okay, so if we want to find the average rate of change, let's go ahead and do that right now. Then let's go ahead and plop in the numbers here into our function. Let's see what we get. So again, if you need to, again, you can label, and put this underneath here. So again, if you need to, if it helps, again, put A here and then B here. So again, A would be a -2 and B would be 5. All right. And all you need to do is plop in those numbers into said formula, and it should be pretty straightforward from there. So let's see what we get. So we get f of 5. Remember, that's f of b minus f of a, so -2. And then we get b minus a, which is 5 minus, meant to put that in parentheses, 5 minus -2. All right. Okay, so because of this fact here, this is what we got to do. Got to make sure we do this. So first and foremost here, let's plug in 5 into the function here. So what's f of 5 here according to our definition of the function? What is f of 5? All right, 28 is correct. Good. Very nice. All right. Let's do minus and f of -2. What's f of -2? -21. Good. 21 is correct. Minus, ooh, careful about that. So, minus 14, not quite for that one. Because in this case here, let me go show off why that's not minus 14. Because you're going to have 2 times negative 2 quantity squared. Remember, this is the reason, right? The reason is because you have to have that minus 2 in parentheses. And then the sign also changes for this as well. Oh no, that's fine. I'm just covering all the bases. So if you do that out, again, sign changes. It always messes people up. Totally understand that. So you get 21 for that. 5 minus negative 2 is 7. All right? So set this apart here. Well, that came out nice. I didn't even plan for that. But it happened. So we get 7 over 7, or 1. All right, so it's actually turned out really good. So that was unexpected, but a nice unexpected circumstance. All right, so there we are, and we got it. All right, any questions about average rate of change? Hopefully that's pretty straightforward. Easy peasy, lemon squeezy. Can I make this into a PowerPoint? Boy, PowerPoints are terrible. I'm not a PowerPoint guy. I had a terrible experience back in the day when I went to U of I for my first year and a half of college. Never again. Technically, I could make it into a PowerPoint, but I like to wing it because it helps adjust myself to everybody else in the class. And so if you have personalized questions, it's a lot easier for me to adjust to that rather than a PowerPoint. For those of you not sure about what I'm talking about, when I was in my second semester freshman year at U of I took a physics class, and the whole physics class was put on PowerPoint slides. And I didn't even know what the heck I was doing because I had no idea what the guy is talking about. He barely wrote any notes. He just point at the PowerPoint slide and it just magically say, "Oh, this works and that works and that works." I'm like, I don't know what you're talking about. And yeah, I didn't do so hot in that class. Well, needless to say, I didn't do so hot that whole semester, but a D minus never really helped at all. And it was after that point that I hated PowerPoints from then on. I'm like, wasted all this money for PowerPoint presentation the whole semester. Psh, get out of here. No thanks. All right. Anyway, are there any questions about section 2.4? No, mope, and nope. All right. Phantom, I know you're sad, but I'm not sure why you want me to mope. It's I'm sitting down in a chair, buddy. Just saying. Fair enough. All right. All right. So, yes, I made yeah, Planet. That's correct. I made a lot of tweaks behind the scenes to not only increase the quality of the stream. I then had to open up some port. I opened up a port on my computer there so I can get the data through faster for you guys. and then I hopefully have made it where there's less of a lag between you typing stuff in on the chat there. So I'm trying to make it more of kind of like lossless or real time. So I'm hoping that this is a really good transition for you guys, because I know that like the last couple weeks we were kind of stopping and stalling and stopping and stalling, and everybody's kind of getting frustrated and stuff. And so like this weekend, that was one of the things that I worked on, is like trying to get this to be better quality than it has been. So if you notice, that's why it was like 1080p as opposed to like 720 or 648, which is, yeah. So I've been kind of fooling around with a lot of my settings on my end to try and pump out this lecture in a much better quality and a higher quality, and at least something that works better for you, so you're not waiting 30 seconds for what you typed out before. Yeah, because I know that that can be very frustrating. I'm still, honestly speaking, I'm still really new to it myself, even though it's been a few months. I'm still tweaking and doing those sort of things. So yeah, I mean, it is what it is. So, but that's not a big deal. I'm hoping that the experience is a lot better for you, at least today, compared to last week. So, my first couple classes here of the day did notice a significant difference. So, if you do feel like it's a significant difference, then great. And that's exactly what I was hoping for. A positive significant difference, by the way. No. So, a negative significant difference means I gotta go back to the drawing board and try everything again. So, all right. Okay. Right. Oh, that's good. I'm glad it's better. All right, let's go to section 2.5. All right. So section 2.5 here is going to talk all about transformations. Okay, so transformations is on the docket here for today. All right, and what exactly are transformations? Well, in order for us to understand what transformations are, we're going to first talk about a few things. We're going to talk about a couple things here, talking about basic graphs. So I'm going to look at question 2 first, and then I'm going to use a specific function in question 2, and I'm going to apply that to a lot of the transformation rules uh, for us to kind of physically see. Um, so we'll take a look at that, and we'll see exactly what we're working with. Okay. All right. So let's look at question 2 here first. I know it seems a little strange, but you'll see exactly where stuff is going to start to fit in once we put everything together. Okay. So, number 2, what are some basic function graphs? All right. So, what we need before we talk about transformations is a basic template of each basic graph. Now, what exactly am I talking about when it comes to a, say, basic graph? Okay, so let's go ahead and go to the Paint tool here. So we're going to first talk about the first basic graph here. I guess we can talk about here is a line. So let's talk about a line here. I never know how to deal with this. Oh, let's go with 1,000. And 1,000. Yay! Good job, me. Can I stretch this? Good, good. Good, good. All right, perfect. All right, that's a lot better for me. Okay. So the first one we're going to look at is our regular old line. All right. Now a line is pretty simple, but the thing that I want to look at here specifically is I want to look at this function right here, which is f of x is equal to x. Okay. So this is our function right here. F of x is equal to x. All right. So if, again, anything I plug in is exactly the same number I get out. All right. So if I have my little XY chart, let's go ahead and just make this over. So if I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in -1, I just get -1 back. So again, we're not talking about something that's super difficult. We're just talking about a super basic graph here of a line. All right. So here we got, again, 1, 1. And you guys are pretty familiar what this looks like. So shouldn't be anything crazy. You got -1, -1, and 1, 0, 0. So as you know here, what does the line look like? Well, the line looks like this. Okay, so there's our first basic graph, which is a line. All right, just like that. All right, like I said, we're just starting with the basics, and then we're going to see exactly how we can, quote unquote, manipulate them or transform them into a different graph. Once we talk about the rules, of course. All right. All right, so let's talk about the next one here. Okay, so the next one here is going to be a parabola. So we're going to go with this function here, f of x equals x squared. So just a simple graph just like that. All right, so again, if we make a little xy chart for that, we have 0, 0, we have 1, 1, we have -1, 1, okay, 2, 4, and so on and so forth. All right, so there we are. We have it. So you've all seen a parabola like this before, so this shouldn't be anything brand new. There it is, my amazing art skills in its all its splendor and glory. All right, so good job, me. All right, yeah. doing great. All right, let's talk about a couple more. Let's talk about a few more here that are quite important. All right, so the next one I'm going to put up here is the next one I'll put up here that's just as common is going to be this guy right here, and I think I want to put. See which one I want to put up next. Debating which one I want to put up next. Yeah, I think I know which is. Are you talking about x squared there, JTS? Because if that's true, then yeah, it's going to be u. Yeah, it'll be a u, not a v. Yeah, that's a great question, JTS. I like that question a lot because what we'll see in just a second will actually reflect that. So actually, to acknowledge that question, actually, I'll do that next. That's why not. All right. So to acknowledge your question there, JTS, let me do this function next. I was going to put this down anyway, but I think to see that proper distinction will be okay. So the next one here is the absolute value of x. So the absolute value of x. So this is another function here that has the same points as pretty much, there is a big difference here. Like, okay, I'll show you one difference here. Like if I were to do this XY chart and I put in -2, -2 would net me 4. Okay, that part is true. Now, I could tell you right now, 0 nets me 0, 1 nets me 1, -1 nets me 1, because again, absolute value makes everything positive. But if I chose, like, say, -2, -2 nets me just +2. Okay, so it's not the same as what we have here for a parabola. -2, 4 is significantly different than that of -2, 2. This is also reflected in the shape of the graph as well. So, what does this look like? Well, here we have again 1, 1, 2, 1, 2, 1, 2. Okay, so here we got 0, 0 just directly in the middle. All right, here we got 1, 1, we got minus 1, 1, so those parts are the same. But then we got this point here, negative 2, comma 2, and we'll plop in 2, comma 2 for the sake of it. So what does this look like? Well, this indeed, to your question here, JTS, this indeed is your V-shape formation here. Okay, so this is where the V comes in. So this is a sharp V here. Okay, so this is like a U shape. And then this is a V shape. So if you take a look at the difference there, the difference is, again, this is much sharper. This doesn't curve. This actually just kind of, it's like an intersection. You know, just kind of comes together like that. Okay, now we're going to be using this graph here pretty extensively in this particular section. So you'll see exactly how I use this. It's actually pretty nice to use in terms of seeing how things work, but just showing it off here for right now. Let's go ahead and take a look at a few more here that are rather important, and I'm going to erase this because I need this space here. That would be helpful. All right, more space, please. All right, so the next one here I'm going to put down that's pretty common for graphs is going to be the square root of x. So if you do the square root of x, square root of x is, again, if we do a little xy chart here, you plug in 0, you get 0. You plug in 1, you get 1. If you plug in 4, we get 2. Okay. 9 is 3, and so on and so forth. In this particular case, we're not using the negative responses, negative answers. We're using just the positive ones. All right, so this graph here is very limited because of its domain and stuff. Okay, so what does this graph look like? It kind of looks like this. Kind of keeps going up like that forever. All right, so that is the square root of x. All right, so a very common function to graph out. So you probably have seen that in some shape or form. All right, possibly when you're doing the math things. Okay, now there are two more functions here, two more basic functions that are used sometimes, but they're not used all the time. So, you know, I'm not going to stress on these super hard, but of course you'll still need to know them in some capacity. So I'm going to go ahead and write these down here, and then we'll look at the, we'll just kind of, I'll just kind of state the graph here. And it's really not too bad. So the first one here, again, you don't see this too often for this. Oops, sorry, messed that up. There we go. So the first one here is x cubed. All right, so x cubed, you don't see x cubed a lot when it comes to graphs, at least not in textbooks anyway. It's used, of course, but just not very often. But at least for reference, I'll put this down here as a graph, you know, like a graphical reference. So as a graphical reference, we do have 1, 1, we have 0, 0, and we have negative 1, comma, negative 1 here. What does this graph actually look like? Well, this graph kind of comes down like this. It kind of curves through like that, and then it kind of comes back up like that. It's, again, not the greatest drawing you've ever seen, obviously, but there's generically what that graph looks like. It kind of flattens out here in the middle. Actually, let me try that again. I'm gonna try that again, everybody. Doesn't look as great as I thought it did. It kind of flattens out in the middle and then comes back up. There we go. Not my greatest work, obviously, but at least it gets the point across. All right. So that's x cubed. And then finally, a very a shape that's not used very often. I rarely see this. I rarely see this shape, but again, this graph used very commonly in examples and textbooks, but still it's listed here, so I'll just go ahead and state this here as well. And that is the function here of the cube root of x. So if you're given here the cube root of x, what does this graph look like? It's very similar to that of the square root of x. The only difference is that you have a negative side of the graph. So you have -1 comma -1. And then you got 0, 0, you got 1, 1. Now the way this graph looks like is this kind of goes up like this, going this way, kind of flattens out, and then kind of comes down like this, kind of goes this way. So it's kind of like a sideways of x cubed, kind of like that. Again, I'm not stressing on this too hard just because these are, the last two here are very uncommon graphs. We do not see those a lot. So just pointing that out there. Are there any questions before I move on? No. Okay. No. All right. I'll go ahead and move on then. Okay. So now that we have those basic graphs under control, all right, that's the answer here to number 2. So what I'm going to do here is I'm going to use one of these graphs, and we're going to talk about the transformation rules. All right, so transformation rules basically means is that we're going to be moving the graph around by doing some kind of manipulation with some of these basic functions, okay? So what does that exactly mean? Let's take a look at several examples. Let's find out what them graphs look like. Yeah. All right. I'm going to go ahead and erase all this and then do the first example. Okay. So let's do the first example here. This is going to be question number 1 on the handout now. What are the transformation rules? So just letting you know what question that's going to be associated with. It will be, go back there for just a second. So, oh, that's not the right handout. It's the other one. So this will be with question 1 here. What are the transformation rules of a function? Okay. So if you're kind of just following along here, that's the one that I'm talking about here for section 2.5. There's only 2 questions anyway, so yeah, that's the thing. All right. All right, so let's go over each example here. I do have some examples to talk about. So, all right. So what we're going to do here is to graph. We're going to graph the absolute value of x plus 2. Okay. So the absolute value of x plus 2. All right. Okay. Let's take a look at the graph here for this particular function. So I'm just going to go ahead and put xy. All right. And you guys tell me what we get here. So let me pick, let's pick a few ones here. Let's pick 0. If I plug in 0, what do I get? 2, okay. 2 is correct. Very nice. I approve. All right. How about 1? All right. 1, we get 3. Simple enough. Okay, how about, let's try one more. -1. About -1. 3? Are you sure about that, JTS? 3? Tree. Pine. Two. Three. Suddenly tree to three. Well, let's just go through it carefully here. The absolute value of -1 is 1. And then you have 1 plus -1 plus, you have the absolute value of -1 is 1. 1 plus 2 is going to be 3. So remember, absolute value here, right? Absolute value -1, 1, correct. Add the 2. That's where you get the 3 from there for this particular problem. Okay. So let's look at the graph here. We've got 3 pretty decent points. So we got 0, 2, which is right here. 1, 3, which is right here. And -1, 3, which is right here. Now remember how it works, right? Remember we said that the absolute value has a V shape, okay? So it has a V shape like this. So if it has a V shape like that, then here's our V shape here. It's not the nicest. I'll try again. Sorry. I'll try again where I don't suck. It's hard when I have a 0 art ability. So okay, so this is what our graph looks like after adding the +2. So let's we'll go ahead and write this out over here on the left. So this will be, actually, I take that back. I take that back. I take that back. I'm gonna put this over here. Actually, that's not the whole screen, is it? Okay. I just like half screen, please. Okay, that works. Okay, so I'm gonna go ahead and put this down here. All right, here we go. All right, so what happened to the graph here in comparison to our original absolute value function? So if I were to compare this graph to the original graph that you had from before, what's the difference there? So, okay. Just the midpoint? Yeah, that's where we got to be a little careful about our JTS. It's not just the midpoint; it's the entirety of the graph. So it's like if I imagine that the graph had, like, instead of a V shape, like it had 2 handles, and I took those handles and just kind of shifted it up. Okay, the entire thing has to go up by 2 units. Okay, so it's kind of like, again, kind of like an all or nothing proposition in this case, anyway. So in general, here's the way it works. If I take f of x here, that is, let me check that. I need to make that bigger. That's what the problem is. Okay. So if I say f of x here, yes, small f, please. If I say f of x plus a, and if you take a look at where the 2 is located, right? The 2 in our previous example here is located on the outside of the function. Okay, so it's not inside, it's outside. So that +2 there. So f of x plus a here for our first rule shifts the graph up by a units. Okay, so this is a vertical shift. Okay, All right. Let's look at letter B. Now, if instead I put minus A, what do you think will happen there? I think you guys know, but if I put minus 2 instead of plus 2, what would happen? Okay, right. That's exactly right. Correct. All right, so you can see how it's pretty simple, right? It's just like, okay, you shift the graph down by A units. Again, A is some random number. I don't know what this number is. It doesn't really matter. But it's a vertical shift down by A units. That part is correct. Okay, so add A, move up, whole graph up, minus A, move whole graph down. Good beans. Okay. All right, any questions about vertical shift? Nope. Okay. So hopefully that wasn't so hard. Okay. I'm going to ramp up the difficulty just a little, just a smidge. Okay. So I'm going to erase this. Okay, and I'm going to do the next one here. So let's do another example. So let's look at, actually plus, I meant plus in the middle there. All right. Okay, so here we have the absolute value of x plus 2. But the plus 2 here is no longer on the outside like it was in the previous problem. Now the plus 2 is on the inside of those absolute values. Okay, so let's make a little xy chart. Let's see what we're working with, right? We know what the shape of the graph should be. We know that the shape of the graph here should be a V of some kind. We just don't know what it would look like. So let's see where the V is located on the graph. So I pick 0, I get 2. Okay. Let's pick 1. If I pick 1, what happens? What do I get? All right, 3 is correct. Okay. Now I know that if we pick 2, we're going to get 4. But the problem is I don't want to keep getting bigger and bigger numbers, because then that doesn't really reflect my graph all that well. So let's go the other direction. Let's go minus 1. Okay, let's go minus 1. If I choose minus 1, what do we get? Okay, good. 1 is correct. How about minus 2? Smaller numbers are a bit easier, so it's true. Minus 2 is 0. Okay. And let's choose minus 3 as well. What's minus 3? I agree with minus 2, 0. What about minus 3? What's that? All right. Correct. All of you correct. The answer indeed is 1. Okay. All right, so let's go ahead and map this out. So let's go to 1, 3. All right, 0, 2. Negative 1, 1. -2 comma 0, and -3 comma 1. So here we go. So we know what the shape is. The shape should look like a V. So it's going to be a V shape here, just like so. All right. No, it's not the nicest thing, but, well, graphs aren't an exact science when you're doing it by hand. Okay. Good, Benz. I got it. All right, so this is our graph here of the absolute value of x plus 2. All right. Now, if we compare this graph here to our original graph, what happened in this case when we added 2 on the inside instead of the outside? Okay, that's correct, right? So if we compare, that's absolutely right. So if we compare our original absolute value graph to this graph that we have up here on screen, this whole graph, the original whole graph, shifted over to the left by 2 units. So that's going to be our next rule here, our next generic rule. So we have, again, put this up to 6 starting. So we have f of x here, f of x minus plus a, I should say. And again, notice I put the plus a here on the inside. All right. So again, this shifts the graph left by a units. And again, as was correctly stated here, a horizontal shift. All right. Is a time, is a life. All right. And I'm pretty sure you can guess what's going to happen next. So let's go ahead and plug it in at the very least. So if I have x minus a, all right, so this would shift the graph which way? If I have a minus a instead of a plus a? That's right. Okay. So just the opposite here. It would shift the graph right by a units. That is spot on. All right. So that is horizontal shift there. No problemo. Okay. Questions about that? None. Zero. Zip. Zilch. Nada. Oh, math. Man. All right. Okay. I can do that. Okay. Let's look at the next one here. Okay. So the next one here is going to be, I'm going to go ahead and erase this one out. A few more examples to show off, but still, nonetheless, pretty important. Oh, no. So let's do this one next. Negative the absolute value of x. So notice here we have a negative on the outside, the absolute value here of x on the inside here. So this negative is separate. So what exactly does that mean? Let's look at the let's look at some points. 0 doesn't change anything. That's fine. What about 1? What's 1 going to be? If I plug in 1 into this function, what do I get? Okay. That's correct, Phantom and Planet. Got a -1. Spot on. If I chose -1 as my x value, what do I get back out for y? Careful here. Careful there, Fidel. Be very careful, guys. Okay, so I'll show this one off here because it seemed to cause a little confusion. So the answer to this is -1. Okay? Now let me go ahead and explain why it is -1 instead of 1. So when you do this problem here, this is what it looks like when you just plug in -1. You plug in -1 in here in the absolute value here for x. I think both of you guys know that really well. The thing is that with absolute value is treated like parentheses, okay? So essentially, absolute value has to come first before we apply the negative here on the outside. So what you actually have here is negative and then the 1 here. And so that's why you get -1 here instead of just the 1. So it's actually kind of the rules and kind of order of operations that you treat absolute value here as a set of special parentheses, basically, that has a unique property to it. Okay, let's take a look at the graph, though. So here we got this, all right? Okay, so there's our graph just like so, okay? So that shouldn't be too much of a problem. So in this case here, what we did is we did negative f of x. So it's like, again, taking the opposite of that original function of the absolute value here. And as you can see in this case, take a look at the original graph and then take a look at this graph. What's the key difference? What's the difference between the original graph and this graph here? Okay, very nice. All right, so it's like if we took a mirror, we took the original graph like this, and then we kind of flipped it over the x-axis and looked like this. Wouldn't it be f of minus x? No, not in this case. What I'm taking here is the entire opposite of the function. So I'm actually taking, that's why minus is on the outside here. I'm not replacing x with, say, minus x, if that's your implication there, JTS. I'm actually just taking the opposite of everything in the function, no matter what it is. So I'm just switching the signs of everything, is what I'm doing. I'll show you another thing there in relation to that question just a second. So this reflects the graph about the x-axis. Okay. So again, just taking it and then flipping it over, and then that's what you get there in that case. Now, in relation to your question there, JTS, this is what the opposite looks like. So if we were to take the other case here, okay, it wouldn't be like, say, f minus x. This is what it would look like here. You're actually doing minus x here, then you do minus x here on the inside like that. So you have f of minus x just like that. And in this case here, it does the same thing, all right, reflects the graph, but about the y-axis in this case. Now, if I did it for the absolute value here, the absolute value is not a great example for this because I would get back the same exact graph that I started with. Because if you have a V and you reflect it this way, well, you just turn it around and you get the same exact V shape as you had from before. So it's like, yeah, you get, it's a little hard to do with the absolute value function, but yeah, you reflected about the y-axis there when you put minus sign on the inside, replacing x with minus x. All right. Yeah, that's fine. I just want to clarify that because it is a point of contention there. So I've heard the question before. It's like, okay, you know, cut that off at the pass so that way it makes a lot more sense. All right. Let's do the next one. Okay. So the next one here, I'm gonna go ahead and do is, oh, well, I guess before I do that, are there any questions, by the way? Any other questions about that last example there? Sorry. Nope. Okay. All right. Next. Let's do the next part here. Yep. All righty. Good beans. All right. So the next one here, there is another one I want to do here actually. So wonder if I want to do it that way. Yeah, maybe I want to. Give me just a second here. Okay. Okay. So, will the exam be open note? I mean, you get a chance to do it online, so I guess question mark. Is there a time limit? That's a wonderful question. Yeah, there's gonna be because yeah, I've debated about that, and I was like, yeah, there has to be a time limit for the test. There has to be a time limit, a plentiful time limit, mind you, enough to get it done. But you know, when is the exam? I haven't announced the exam yet, Andy. Um, the exam here is going to be either will be announced either the next class or next Tuesday. When I make that announcement there, the actual exam will be a week from that announcement. So I always give a kind of a week, a week ahead of time, kind of worth a warning there. So once I make that announcement there, then the test will be due a week from that announcement. So to make it as fair as possible, and so it'd be you know easier for you to do with the notes that you got. And that'll always be true for the course for the remainder of the semester, by the way. So I always like to give a word of warning, so that way it's like, oh, I wasn't caught off guard. I'll add an announcement on the on D2L there as well, to say, oh yeah, we got a test that's due, you know, on such and such date or something like that. Yeah, I wouldn't leave you hanging in the dark. Be like, you gotta get done tomorrow. Have fun. Like, that sucks, bro. I couldn't do that to you. That's too mean. So, oh, why did I put -2? I meant to put 2, just 2. Okay. So this is the graph here of the absolute value, 2 times the absolute value of x, okay? So this is the graph here that you see on screen. All right. Now, if you were to compare this graph, okay, to the original graph, what's the difference that you see there? Actually, I wonder if I can put that on the same thing. So let me see if I can put it on the same same graph here. Second. So I put a little comma here. There we go. All right. So yeah, so the one in blue is the original function. And the one in green is the 2 times the absolute value of x. So the angle is smaller. Yes, that's correct. Okay, that is absolutely spot on. All right, so you can see like it went from a kind of a wide V there that you see on the blue line there, and now it's like a much more narrower kind of a V, you know, now that we added a multiplier of 2. Okay, so we can actually get some information from this. So we're going to write down another transformation rule. Okay, so let's go ahead and put that down. Okay, so let's get to our list of rules here. All right, and there's going to be a couple of things associated with this one. So if we have, say, for example here, C, well, obviously you need that. Okay. C times f of x. Okay. I'll put a little times symbol there. So what is C here, by the way? Just to be clear about what C is. C is a constant number, okay? So C is a number. C is a constant number. And also in this particular case, we're going to look at a couple of things here in relation to a constant number. I guess a constant positive number. I guess I'll put it that way. Constant positive number. All right, in any case, let's talk about the rule associated with this. There's 2 cases. If C is bigger than 1, okay, so if C is bigger than 1, meaning like, again, the 2 or the 3 or the 4 or whatever, okay, doesn't really matter here. All right. Then the graph will get this here. Right. Then the graph will vertically, all right, let me put this here. Vertically stretch and horizontally shrink. Okay. And that is if C is bigger than 1. So it'll vertically stretch, all right, and it'll horizontally shrink. So again, it's like I took both ends of the graph, both ends of the absolute value graph, and I kind of pushed them together, pushed both ends together, and I got that new 2 times the absolute value of x. Okay, so if I were to talk about it horizontally it shrunk because I kind of pushed them together. But vertically, I stretched them out because now it went up faster like this. Okay. Now there is a second half to this rule, and that is in relation to, if you see here, I put C is a constant positive number. It's actually really important here, because if it's a negative number, a negative number is like a reflection, okay? That's the reflection about the x-axis here. So negatives are taken out because we already had defined our two rules from before. I know that seems a little weird, but we're actually taking the negative as a separate rule than that of just a regular number. But they do both have their equal meanings here. So in this case, because C has to be a positive number, in this case what we want to do is if we have C is between 0 and 1. So let's say C is between 0 and 1. So we're talking a half, a third, okay, a tenth. Let me show this off here. You could probably guess what's going to happen here, but we can see it visually here on the graph. So let's go ahead and look at that right now. All right, so I'll go ahead and put down one more here, one more graph, and we can kind of compare and contrast the two. So I'm going to go ahead and put in I'll go ahead and put in 1/2. Something happened. Wait, hang on a sec. Why did that happen? So 1/2 the absolute value of x. Okay, so that's all we're going to have there. And so let's go ahead and take a look at the graph there. All right, so I want you to note the difference here. So the blue graph here, once again, is the original graph. The green one here was 2 times the absolute value of x. And then this kind of grayish line here, yeah, grayish, that's what I can see, again, is the 1/2 times the absolute value of x. All right. So this is your function right here. So if you see there, it's like if I took both ends of the graph again, kind of like as handles, or like, two pieces of steel rebar, and instead I'm trying to Superman it. I'm trying to kind of pull it apart like this, okay? All right? So I'm just pulling it apart instead of, crunching it together, like that. So you can see that the graph here is significantly flatter horizontally, but vertically it shrinks. And that's what happens here in this case. Again, if you look at the graph, it happens for that exact reason, is when you have that fraction between 0 and 1, it actually does the opposite. So let's go ahead and write down our rule here. So if C is between 0 and 1, then the graph will vertically shrink and horizontally stretch. Okay? So there is a distinct difference between the two in that case. We do have one more rule to go over really quick. This one here is the last rule, so let's do letter H, I guess. All right, so the last rule here is if you see on letter G, C is on the outside here. So what would happen if I put like the constant here on the inside of the function? So like the absolute value of 2 times x, put the 2 on the inside. Well, turns out that, again, we're going to have our same thing here. So C is a constant positive number. All right, so same idea as the one from before. And so we're going to have our two cases. So if C is bigger than 1, all right, so once again here, then the graph, again, horizontally shrinks and vertically stretches. All right, and once again here, if move that down, if C is between 0 and 1, then the graph horizontally stretches and vertically shrinks. So the same, again, just the opposite behavior as the previous one. So there we go. Okay, good. Are there any questions about that so far? Those are the basic, those are all the rules of the, all transformation rules right there. We're now able to do some examples now that we've kind of stated everything. So there's just a lot to state in this section. So it's a big information dump really. But once you get it, you're like, oh, okay, it's not so bad. Okay. Oh, I'll wait for a few more people. They might still be writing stuff down. So wait for you guys to write some more stuff down there. So should be pretty easy. Hopefully. Question mark. Okay. Does anybody else need a little more time, or can I move on? I don't know if you're still writing stuff down there. So. No. Okay. All right. So I'm gonna go ahead and move on here. All right. Okay. Just making sure that I know there's a lot of information there, so which I totally understand. Just want to be able to make sure you have those in your notes or whatnot, wherever you keep them. So, all right, let's go ahead and try some examples here finally. And with these examples here, let's see. We're going to just describe the transformations here. Okay. So when we try and describe the transformations here, and then if you want to graph it, we can go ahead and graph it. So because they're going to ask you to graph it, but really they're going to ask you to, kind of how you would describe the transformations and then graph it. So let's go ahead and take a look here at a function. Sure. Which one I want to do? You know what? I'll do it that way. That's fine. Okay, so I'll put it on the paint guy here. So let's go with f of x is equal to the square root of, let's go with negative on the outside, x plus 1, just like so. All right. So first and foremost here, let's identify a couple things, okay? First and foremost, what is the original function here? What's the original function that we should look at? Because you got all the basic functions there. So which basic function should we look at? Okay, square root of x, right? So our basic function here, so we know what we need to look at, right? Right, square root. So what we're going to do here, our basic function here is going to be the square root of x. All right, so that way we know what the graph should look like. Okay, in it should, at the very start, it should look like that. This shape here. Okay, so it should look something like this. Okay, whatever. All right, there you go. As long as you have a general idea about what the shape looks like in your head, then you can start moving it around and then have a pretty good idea about what the shape should look like after moving it and doing all that jazz. Let's talk about the transformations. This is our basic. Our basic is going to be square root of x. All right. Okay, so what happens in this case? Let's take a look. Let's take a look at the plus 1 on the inside here. So what should happen to the graph with the plus 1 on the inside? Okay, moves 1 to the left. Okay. All right, so again, if we know where we're starting from, we're going to take that horizontal shift. We're going to move that left. Completely agree. All right, we also have one more thing in here. We have this minus sign on the outside. So what should happen then? Okay, reflects on the x-axis, right. Right, so we're going to shift it left 1, pop, and then another pop, bring it down, I'm going to reflect that. So you should have it in your mind's eye about what that graph should look like. And once you have it in your mind's eye, be like, okay, I have a really good idea about what this graph should look like. Let's go ahead and just map it out on a graph. So I know where to start from, and then I know what to do after that. So I could start from technically minus 1 because I'm shifting it left and then putting it down. So I go minus 1, I could get 0, and then I could keep going if I wanted to. Again, I could go with 0 here. 0 would be minus 1. All right, and so on and so forth. What will be the next one here? 3. 3 would be minus 2. Again, you can get these on your calculator if you like. I'll show you in just a second how to do that. You're going to have a little graphing calculator session with this, so hence why I wanted to do this problem as well. So negative 1, 0 here. I'll show you a few things that you can do on the calculator there, so that can be fairly helpful. So what does this graph look like? It kind of looks like this. There you go. And that's your final answer for this problem. Any questions about that? No? Okay. Just checking for something here. All right. is what it is. All right. Okay. So what I'm going to show off next is how to use the calculator to get these graphs. Let's go ahead and try it with this nice easy one here, and then hopefully it'll be a little bit easier. Uh, hopefully it'll be a little bit easier for the next one. So let's go ahead and met this out. All right. Let's probably may buy a license for that. Okay. Oh yeah, right. There we go. There. So let's make this screen a bit bigger. Hey, there I am. Go team. Yeah. All right. There's my face, all in its 1080p glory. All right. Anyway, that's beside the point. What is my point today? I don't know. Oh, right. That is my point. All right. So let's go ahead and show off how to do this on the calculator here. And once again, if you have your Mr. the Graphing calculator right here, okay, go ahead and follow along with me here. And we'll go through the steps here on how to graph a function on the calculator. Now we're going to be using this friend here for several concepts throughout the course of the semester, so at least getting used to it now will be very, very helpful. All right, so the first thing that we're going to want to do here on our nice little screen guy here, probably hopefully we'll get an emulator soon for maybe buy the license from TI to get the SmartView stuff, is to hit the y equals key right here. Okay, so I'm going to want to hit the y equals key right there, and we'll get to the y equals menu. All right, and why is this so low? Coming. All right, there we go. Okay. All right, next what we're going to have here is we're going to go ahead and enter in the function. Now to enter a square root function, you're going to hit the second key and the x squared key, and that will bring up the square root little thing, so the square root symbol there. Oh, I forgot the negative. Let me put the negative, sorry. Oh, right. One other thing about the calculator, it's very particular about how you enter stuff in. I'm so sorry. You want to actually use the negative key and not the minus sign key. It really hates the minus sign key. If you use it in the front, it'll spit out an error at you, and then it won't like you. So, yeah, you want to put that negative on the outside. You want to put the second and x squared. That'll get your square root symbol. And then you can go ahead and hit X here, which is right here next to the alpha key, X plus 1, and close parentheses. Now, if you want to take a look at the graph and what that looks like, you can. Okay, so we can go ahead and hit the graph key at the very end here. I don't know if you guys, I know it's not the best here, but got to make do with limited resources here. Okay, so there is our graph that we meted out on the screen. All right, so that shouldn't be too bad. Okay, now what if we wanted to take a look at points? Okay, so if you wanted to look at the table of points, you can hit the second key and the graph key. So if you hit the second key here and the graph key, that will take you to the table here of points for this graph. Now, I didn't set my table yet because, well, I'll do that in a second actually. But so here's a table here. So if you see this, this is our table of values. Again, not so easy to see, I know, but I'm just trying to go over kind of some of the basics here. So you can see the table of values there. We will see again -1, 0, 0, -1, and so on and so forth. All right, so they have a whole list of values there. One thing that's going to be important later on in the semester is at least a concept that's going to use this table rather heavily. So I want to kind of talk about it now. The thing that we can do here in this particular case is in the table that you see here, we can pick and choose the values we want to try with the function that we plugged in into the y equals menu. So the question is, how am I able to do that in the calculator? Okay, so for us to do that here, what we want to do here next is hit the second key and this key, which is the window key. So if you hit the second key and this key, which is the window key, it will take us to what's called the table set menu, and it'll look just like what you see on the screen. Okay. Now at the very top it says table start. You can start at any value that you want. So typically start at 0. You can start at -1 if you want. It doesn't really matter. The next one here talks about what your increments are going to be. So 1 unit at a time is pretty typical, unless you want to try other smaller or bigger increments. You can, but typically 1 is the default, but you can change that if you want. All right, but the one that we want to look at here specifically is the third option, which says independent. So we're going to kind of scroll down to that option there, and it's going to go to auto. We want to switch it from auto to ask. So just highlight ask and then hit enter. Okay. Then go back to your table. So second and graph to go back to your table. What you'll see is you'll see a blank XY chart, just like so. This is supposed to happen. So if you don't see any numbers in there, that's okay. That is not an error. All right, that is supposed to happen because now you can plug in any number that you want and you can see what you get for your y value. So for example, I try -1 in my X chart and I push enter, and out will pop the answer, which will be 0. And there you can see that's our point, -1, 0. I try 0, and there we go. I get my answer here of -1. So you can see that the calculator here is pretty robust and very strong in terms of doing certain calculations once you know how to manipulate it in your favor. So I just wanted to point that out because that happens to be something that we want to be comfortable with once we get to that point, those concepts that are going to be using the sky more and more heavily. Are there any questions about that? I hope that was clear in terms of how to use the calculator, because that's like really super important there, you know, because we're going to be using that quite a bit. So, you know. Any questions about any other you guys are good. Any questions about calculator stuff before we move on to the next example? No? Okay. That's perfectly fine with me. Okay. Nope. All right. Good beans. Okay. So let's go ahead and do another example then. We can go ahead and move on. And let's go ahead and see what will happen here for the next one. So let's go ahead and try that out. That's fine. this next example here. Let's do f of x here is equal to yeah, let's do that one. Let's do 3 x minus 2 plus 4. Okay. Now in this case here, we're going to go ahead and just describe the transformations. I'm not actually going to go ahead and do it out. So not in that case anyway. But I will show you on the calculator how you would actually do this. I think that's equally as important for like absolute value and stuff. So in any case, yeah. Sorry, Kurt. I totally forgot. I'm so sorry. Let me go ahead and do that right now. That'd be helpful. Like, I don't want to stare at your face. Be like, yeah, I don't disagree with that. So, there we go. A lot better. I understand, I understand my charisma, all right? I know if I roll my charisma check, all right, I know that it'll never pass. I get it. Okay, I know that's why you want my picture shrunk down. I understand. Okay. All right. So here's our here's our function right here. Okay. So let's talk about the transformations. So let's look at them. Just kind of type out what the transformations are here. So how about that 4? What's that transformation for 4 there? What's that plus 4 mean on the outside? All right. Good. So shift up 4. Okay. Good, good. How about the minus 2? Okay. Wouldn't you start with what's closest to x? Right, 2, yeah. Wouldn't you start with what's closest to x? Well, what would be closest to x in your opinion, JTS? Minus 2? Not minus 2 in this case. Like, okay, let me go ahead and describe why I wouldn't choose that. Well, again, all right, so imagine for example here, in your head, you're moving that graph up by 4 units, and then you're moving it to the right by 2 units. So that means that if you start at 0, 0, you move up 4 units, and then you move over to the right by 2. So you should start at x is equal to 2, and then kind of fan out from there, because that's what the graph is going to generically look like, right? So it's like, okay, I move up by 4, so it's like if you have the graph here, right, and you have 1, 2, 3, 4. So this is kind of like what my mind's kind of seeing here. I move up 4, so I know that the graph is up here. I move over 2, so I know that this now moves over 2. So now that this moves over 2, that point is going to be right here. So I probably should start at x is equal to 2, at the very least, from those 2 positions. Shift down 2. No, we want to shift up 4 here, because again, plus 4, planet is on the outside here. So if it's on the outside, this is a vertical shift, okay, if you see it on the outside here. If we have the minus 2 here on the inside, okay, remember minus 2 here will be our horizontal shift. Okay, so horizontal will be inside, vertical shift is outside. How about this 3? How about this 3 here? What does that 3 do? Okay, vertically stretch and horizontally shrink, correct. So let's go ahead and say this. Vertically stretch, horizontally shrink, again by a factor of 2. Oh, 3, sorry. My bad. Okay, so what is this graph going to look like? Let's take a look here. Now, if we want to see what this graph looks like, all right, we're going to want to go hit the y equals menu on our calculator here once again. And we want to be able to enter in this entire function that I have written up here. So let's go ahead and write that down right now. So we're going to hit 3. Now to find the absolute value key on your calculator, okay, and I guess I'll write this down here. So, excuse me, let me check that. Right. So you want to go to a certain menu here if you're going to find the absolute value here. So on your calculator, you should hit the math key. Hit the math key. You'll get to that menu there, where at the very top you see Math, Num, CPX, and PRB. You want to go ahead and hit the right arrow there. So you want to go to the Num submenu. NUM submenu. After that, that very first one there, you want to choose number 1, which says ABS. ABS with a parenthesis next to it, that is absolute value. If you have the newer calculator, it will then transform into those absolute value symbols. If you have the old school calculator like mine, it will just have a parenthesis next to it where you plug in the absolute value of x minus 2. And then close off the parentheses and then add the 4 there at the end. You can go ahead and hit graph. And again, if you want to get back to your, you can write an XY chart here, okay? So, you know, if it helps, you can make an XY chart here. So again, you start at 2, for example. At 2, you get 4, and so on and so forth. You know, try 3, because I'm just picking 2 values around 2. Here we get 7, and if we try 1, we also get 7. So again, if you need to take a look at those points, again, you can go and plug in 0, 1, 2 into your table there. That's perfectly fine. So what does this graph generically look like? Let's go ahead and put this down. Okay, so here's 2 comma 4 here, 3 comma 7, 1 comma 7. So again, it's going to be a pretty narrow V here, and there we go. All right, and there we have it. That's going to be our graph. Are there any questions about that? Wow, my handwriting's terrible today. All right. Yeah, that one's pretty simple. So let me check that here. Will we use a graphing calculator on tests? I mean, you'll need it to answer that question there. You'll need it for certain problems. You'll definitely need it for certain problems. So you'll use it, yeah. You can obviously use it on every test. I don't mind if you use the graphing calculator for every test. But you'll need it for certain calculations, that's for sure. Yeah, there are going to be certain concepts we're going to pretty much lean on the calculator there. So it won't be surprising that that certain things will kind of revolve around that. Let me check that here really quick. Okay, that's fine. Yeah, that's okay. That should not be a problem. Okay. Yeah. All right, good beans. Questions, comments, concerns, complaints, conquistadors. Nope. All right. Good stuff. All right. So for next time, we're going to get through 2.6 and 2.7. All right. So that is the last two sections there of chapter 2. All right. Is 2.6 and 2.7. All right. So that's going to be our last one there. You have a couple questions after class? Absolutely. I'll be more than happy to take those questions there. So, but that'll end our regular class here for today. So for those of you leaving there, I wish you a very good evening. All right, I will see you on Thursday. Hopefully we'll get through those two sections there, and then I will be announcing the test once we are done with that. All right, so that'll take care for today, everybody. We will see you later. And JTS, I will take your questions. All right. Everyone else have a great one. All right. Take care of yourselves. You're welcome. You have a wonderful night. See you in a couple days. Okay. All right. Let's go back there for just a second then. That's fine. Let me all right. So for G, like the one on the outside, you don't see the so when C is bigger than 1, horizontal shrink, but not the vertical stretch. All right. So let's go back to the website there for just a second. I'm going to look at the graph there. So let's take care, Planet. You have a great one, my friend. All right, so let's compare the two, okay? JTS, let's compare the two. All right. So I'm going to first put down the regular absolute value graph, okay? So just the regular one. And then I'll put the other one here with say we'll go to 3. We'll go to 3 absolute value of x, okay? So I'll make it a bit bigger. Okay. So let's go ahead and take a look at both and we'll compare them, all right? Okay. So the one in the green here, or yeah, the one in the green here is going to be dark green, is going to be our regular absolute value graph. And the one in the blue is going to be 3 times the absolute value of x, so 3 times this original graph. So I can totally understand you can see the horizontal shrink, because again, it's just kind of coming compact like this. The vertical stretching comes from the fact that the ends of the graph, look at how wide they are. Okay, that's again looking at it from a horizontal perspective. You see that it's much wider horizontally, comes together, it's horizontally shrinking. I know you can see that without a problem. Now let's look at it from the other side though. From the vertical side, this is kind of like in the middle here. It's kind of like looking like this. All right, but if we look vertically, it's like if I took those ends, it's like if I had a rubber band, right? And I had like two ends of a broken rubber band and I stretched it up like this. Well, vertically, it's going to shrink because now it's not out like this where it's like going up slower over a vertical distance. It's now going up faster over a vertical distance. So that's why it's vertically shrinking in that case, or vertically, that's why it's vertically stretching in that case, I should say, sorry. That's why it's vertically stretching in that case, because it goes up faster in a shorter amount of time. So that's the reason why you actually have it in that case, is like you see vertical, it's like, oh wow, it's going up really fast in a short amount of time, so it vertically stretches. Okay, if it's like the same thing as like an exponential function. If it goes up really, really fast in a very short amount of time, that too would be an example of a vertical stretch, if you kind of want to put it that way. So, um, does that make sense, JTS? Do you see that here? Like if you're trying to compare the two, it just kind of like you just kind of have to like change your perspective here. So horizontal is pretty easy to see. I don't disagree. It's the vertical part I understand that you're having a little trouble with. But if you take a look, if you like grab it and you like a stretch it in a rubber band, well, it goes up faster over a vertical period of time, so it'll vertically stretch there. That's why. Okay, let's take a look at that too. Okay, that's fine. Let's take a look at that too. So let's change it up. All right, so I'm no longer going to have 3. All right, I'm going to change that to 1/3. Okay, so let's change that to 1/3. All right, so just like that. All right, so that's between 0 and 1. All right. So let's compare it to the original graph and let's see what we have. Okay, so the green again is going to be our original graph. All right. That's okay. That's why we're going through this carefully. No problem. Okay. I'm here to help. Don't worry about it. We're just trying to change your perspective to see it a little bit easier. Okay. It's not so easy to see right away. So, I'm not expecting you to get it like this. 1, 2, 3. We could go slow and we can answer those questions. All right. All right. So I want you to take a look at this. This is again the green is our original graph, and this is going to be our again our 1/3 times the absolute value of x. So now we do indeed have a number between 0 and 1, as you suggested, and you have a trouble seeing the horizontal shrink. All right, so take a look here horizontally from that point of view, JTS. Don't you feel that that graph is much flatter than what it was before? That would be a horizontal stretch, by the way. I think I think you have that backwards. Let me check that. I think you got that backwards. I think that should be a horizontal stretch. Yeah, you have that backwards there, JTS. It should be vertical shrink and horizontal stretch for between 0 and 1. Let me go ahead and put that up again for you. So if you see here for letter G, if it's between 0 and 1, vertically shrink and horizontally stretch. Make sure you... Yeah, no, that's fine. I saw that... but you can see this, right? You can see this, JTS. You can see that it's horizontally stretched out because, again, it's much flatter than it was originally. So again, it's much more stretched out than it used to be. And vertically, if you're just talking the y values, it's much smaller. Okay, it goes up a lot slower than the original graph here, so it would vertically shrink as a result because of that 1/3 I put there instead of having the original just regular absolute value function. Okay, sometimes it's just a matter of perspective, that's all. But if you can see it now, that's great. Can I abbreviate when f c of x, it's a constant positive number? Yeah. So there's not really an abbreviation for it per se, because yeah, I mean, I could say that c is a non-negative number. That's the only kind of abbreviation. Or I could say c is bigger than 0, I guess. But I don't want to confuse that with the two rules that I have down here, because then that gets more confusing than it needs to be. So that's why I'm just kind of pointing out here. Now I can do this. I can put like the times like that inside the parentheses if that makes it a bit easier. You just let me know. So put that here. Oh, okay. I mean what it means. So basically, c can be any constant positive number, meaning to say it can be, it can be 5, it can be 10, it could be, 1/2, it can be, anything. Is it the same as step G? Yes. It's the same. It's the same as step G here. Correct. Same dealio. Correct. I just put it in there so again you note that it's it's the same meaning as what you had in G is in H. So each of one of those rules there again will apply. Apologies if I didn't understand the question the first time. uh yes. Yes, you're correct. It is the same as, it's the same exact thing, yes. Same as G. The reason why I put it as a separate rule is because the constant number's on the inside as the outside, but really, in reality, yeah, you actually get the same result. That's correct. Yeah, I probably should have stated that. That's totally my bad on that one. I need to make that more clear. So, hey, no, you can look. You can ask me anytime. Okay, I'm here to help you. All right. I want you to be on the same page. I want you to understand the material as best as possible. I'm here for you. So if you have questions, I'll be more than happy to answer after class. That's fine. That's okay. Hey, you want to wait? That's fine. After class, that's fine. You ask me anything. If you need to stop me because it gets too confusing if I'm going too fast, just feel free to stop me. That's okay. Like I said, I want to help as many people as possible to be on the same page. So again, so the material is not very overwhelming because I know college algebra in general can be really overwhelming. So um, yeah, I just want to be sure that you're in a comfortable place in terms of understanding the material. You have any more questions there for me? Guess I should ask that first. All right, JTS, we'll see you on Thursday, okay? You have yourself a wonderful, wonderful night, all right? You too, my friend. Take care. Yeah, yeah. Anybody have any more questions that they want to ask? All right. Well, that's okay. I don't mind whatsoever. Alrighty. Okay, everybody. Well, I want to thank you all for coming out today. I appreciate the time, and I will be back here on. I'll be back here on tomorrow for Math 097, but I'll be back here for College Algebra on Thursday. All right. I wish everybody a safe and wonderful night. Stay safe and stay healthy. Have yourself a wonderful day. Take care, everybody. See you tomorrow. All right. Bye.